Okay, our worksheet today, called a graphing practice, does any of this stuff up here look familiar? Yeah, so what I want you to notice is that our worksheet today is kind of gathering all of the stuff we've been doing the last couple days and just on one problem. We're putting it in one place, okay? So let's remind ourselves how to do all this stuff up here at the top. You ready? How do we find a vertical asymptote? God bless you. How do we find a vertical asymptote? Yes, we do math. That's correct. What specific type of math do we use? We set the denominator equal to 0. Good. Set the denominator equal to 0. Okay. How do we find the horizontal asymptotes? Now, finding vertical asymptotes, that's a one-step kind of deal, right? We set the denominator equals 0 and solve. We got a couple of steps to do in solving, but then it's done. Horizontal asymptotes is not exactly the same, is it? It's a little bit more involved. What's the first thing we have to do when we're determining horizontal asymptotes? We have to look at the degree, right? Okay? So we're going to write look at the degree. Well, degrees, I guess, plural, because it really depends on what the degree of the numerator and the denominator is, what you do. Now, I did give you a really great worksheet the other day called Finding Horizontal Asymptotes. You remember that one? Thank you to those of you who are paging through and looking. That's a really good worksheet to go back to if you're struggling with horizontal asymptotes a little bit. Okay, so you might want to have that out when we're working on this. Okay, what about this one? How do we determine points of discontinuity? Factor. Good job. It's almost as if we've talked about that one before. Factor. Factor what? The whole thing, right? The numerator and the denominator. What are we looking for? Specifically in the numerator and denominator, we're looking for common factors, aren't we? We're looking for one that happens in the numerator and in the denominator. Same factor. That'll tell us the x-coordinate, at least, for the point of discontinuity. Okay? You okay so far? All right. So then we want to draw the asymptotes with dotted lines. Why dotted lines? Because they're not actually there. Yeah. It's telling us nothing's here. Right? Then we want to make a table of important values. Well, what would be a value that would be an important value? So for sure the asymptotes, right? And maybe something on either side of the asymptote to help us out with that, right? Okay. Then we want to plot the points from the table and sketch the graph, and then we want to identify the domain and range. Now the good part for me is that in the past, when we've done problems that say identify the domain and range, there's been an audible groan. Ugh. But I've sensed a change since you guys worked on your project. Is that true? Are you feeling a little bit more confident about domain and range since we worked on our project? Good. Okay. If your answer was kind of, that's still good. Kind of is better than it was, right? Okay. So let's work on this. Now, some of you have a problem with this because you want to do this one, then this one, then this one, then this one, then this one, because that's the list and we got to go in order. No, we don't. It's not always the best way. These are all the things I need done, but we can jump around if we want. I mean, it's a song, right? Jump around, jump around. You don't know that song? Okay. It's a good song. Okay. So where do you want to start? What would you do first? I would fill in the table. Right? Now, plus the fact that we're here and we have calculators together. Do you have a calculator at home? No, maybe we want to get our table all filled in first, right? Okay. Now, notice the first one is kind of our sample, and it has the table values filled in. So I'm kind of throwing you under the bus a little bit here because I'm not talking right now real quick about how to choose the values, but we did kind of talk about it up here, right? Important values, for sure the asymptotes, and then values around that. Okay? Got it? All right, so let's fill in this table. Go ahead and put this equation into your calculator, and let's fill in this table. Turn your calculators on first. Yes, that's important. It is. Yeah, I think it says on. Oh, it doesn't say on? Oh, house. Okay, so press house. Okay, so you got this in y equals yet? Are you using the fraction key or using parentheses? Fraction key it makes it visually the same as what's on the paper. So some people like that better. What you got? 13. Negative 4. Undefined. Ooh, that should tell me something, right? Okay, negative 3. Negative 7. 1. 1. If x is 1, y is 1. What about 2? 1.3 repeating. What about 4? Ooh. And then what about 6? 2. Okay? So, can I really graph this yet? Not exactly. I mean, I can graph the points 1, 2, 3, 4, 5, but I don't know what's going on here and here yet, and I won't until I figure out what this stuff is. Okay? Of vertical asymptotes, horizontal asymptotes, and point of discontinuity, which one's the easiest to see visually? Like, as far as looking at the equation. Horizontal asymptotes, right? Because all I'm doing is looking at the degree. Remember, that's what we wrote up here? Look at the degrees. What's the degree of the numerator? 2. What's the degree of the denominator? 2. Remember what degree is? Highest exponent. Because these are the same, what do? I divide the leading coefficients. What's the leading coefficient of the numerator? And the bottom, and the denominator? 1. So 3 over 1 is what? So it's a horizontal asymptote, so it's going to cross the y-axis at 3. Can I go and plot that on the graph? Oh, yeah. Yeah, me too. I hope so. Okay. So do you want to do vertical asymptotes or points of discontinuity? Vertical? Okay, so how do we find vertical? Set denominator. So x squared minus 16 equals 0. So if I add 16 to both sides, I get x squared equals 16. And when I square root, x equals what? What's the square root of 16? Thank you. Plus or minus 16. Remember? Remember that? We put the square root in there, so we have to put the plus or minus, right? So are both of those vertical asymptotes? Ooh, I don't know that, do I? Not until I factor numerator and denominator to see if any one of those is occurring in the numerator, do I? Okay, so let's go ahead and factor this to work on points of discontinuity. So is it weird having to jump around and put together what we know? No, it shouldn't be, right? You learn how to throw a free throw, right? Everybody, you learn that, right? In basketball, you learn how to throw a free throw. But what happens if you're dribbling the ball around and you end up right on the free throw line? Do you have to stop and ask everybody to pause for a second and then bounce 3 times and then shoot? Or do you have to figure out how to adapt that into the game? Oh, so it's like math. Of course it is. Okay. So if I'm going to factor the numerator, so AC is negative 24, so it multiplies to be negative 24 and adds to be negative 10. Negative 12 and 2. Okay? So I have 3x squared minus 12x plus 2x minus 8. Good. You remember this? Factoring by grouping? So then I look at the first two, and I take out a 3x, and I have an x minus 4 left. I look at the second 2 and I take out a 2 and I have an x minus 4 left. Can I write down here? Is that okay? So in the numerator I have 3x plus 2 and x minus 4. In the denominator, I already solved for my denominator, so I know I have 2 factors down there. And I know one is x plus 4 and I know one is x minus 4, right? So what do we notice in the numerator and in the denominator? There's an x minus 4, right? So what does that mean about x minus 4? That's my point of discontinuity, isn't it? Where is it again? Well, here's the deal. I know the x-coordinate of my point of discontinuity. Yesterday you were just asked for a line of discontinuity. Today it's specifically asking for the point. It wants to know the exact point of discontinuity. So let me tell you how to find that point. Okay? I know, I set these equal to 0 and solve for that x value, right? You okay with that? That's why I have positive 4, not negative 4. You okay with that? So now I'm going to ignore that. To find the y value, I'm going to put it into this fraction right here. What is 3 times 4? 12 plus 2? 14. What is 4 plus 4? Okay, so then what is it? 14 divided by 8? 1.75. That is my exact point of discontinuity. Is that something I can plot over here? 4 and then 1.75, so like right there. There's a hole. There's a hole on my graph right there, isn't there? Okay? Well, if I know that that's my point of discontinuity, my hole, what does this other one tell me right here? Yeah, the vertical asymptote. Set it equal to 0. What do I get? Very good. X equals negative 4. Crosses the x-axis at negative 4, so I can go ahead and draw that in too, can't I? So now what? I got to do domain and range, and then I got to actually plot it, right? I have to graph it. What do you want to do first? Yes, so some people like to graph it first so they can see it better for the domain and range. Okay, so we can go do that. Negative 5, 13, somewhere up there. Negative 4 is undefined. Okay, that's good because I have an asymptote there. Negative 3, negative 7. It's right there. 1, 1. 2, 1 1/3. 4 undefined, but I already know about that one because that's where that hole is, that point of discontinuity. And then 6, 2. Well, this side I can see pretty easily, right? Except I know that rational functions look like that, don't they? So if I have one side right here, because of the information I have, if one side's right here, where's the other side? Like up here? Down here? No, it even gave us a clue, right? With this one point. If I looked at my graph on my calculator right now, it would look something like that, wouldn't it? Yeah. Could I go and figure out negative 6 and negative 7 and negative 8 in my calculator if I wanted to? Yes. It's not that it's too much work, is that it's almost unnecessary work because we have enough knowledge based on what we know about the parent function to go forward. Okay? So now let's talk about the domain and range. How far to the left does this go? And then what happens right here? There's an asymptote, right? And then what happens right here? There's a hole. And then what happens? To infinity again, right? So remember there's two ways we got to know how to write domain and range. Here's the first way. All real, but x is not equal to what? We're just talking about x values. negative 4 and positive 4. Here's what it looks like the other way. That's a little crazy. I know that. Let me make sure you understand it. All the way from negative infinity to negative 4, and then I can't count negative 4 because there's an asymptote right there. But right on the other side of negative 4, it starts again and goes to positive 4. But right then on the other side of positive 4, then it goes to infinity. Does that make sense? The range, all real, y is not equal to 3 and 1.75, because that's the y value of this whole. So it looks like negative infinity to 1.75. It starts again at 1.75 and goes to 3, and then it starts at 3 and goes to infinity. We can talk about domain and range tomorrow a little bit before we get going if you would like to. You just have to ask questions, okay? So get as much done on these as you can, and I will check them tomorrow. Come to tutorials to ask questions before school or after school, or to use a calculator. Any questions? Good job. Peace.